So I'm going to show you what lab is today. Lab today is no computers required, right? No thinking involved. Just I need your artistic abilities today. You're going to produce something that looks like this. Let me go ahead and pull this up for you. This is your goal for lab today. Something that looks like this, but better, maybe? Yes. I'm going to draw this a little bigger. This is like the drawing that I've been making the whole time, but in more detail. So it's like we start here and we go to the server, but you'll see that like it sends the request and it comes back with the city and then it sends this response back. And you'll notice that it has the file name and the line number and the function that gets called. So I've been drawing these lines. You're going to draw the line and what file number and what function it goes to, and then what data comes back. So this is going to be your way of kind of mapping out the entire system from start to finish, the whole City Explorer.
So these numbers are the steps?
These numbers are the line numbers. So you're going to say like, server.js line number 52, asks for this data, does this work, brings back. So however you want to draw it is up to you. I've seen this drawing done on Lab 10, which is today, probably 100 times, and never seen the same drawing twice. Every set of students draws this differently. It's kind of how your brain sees how all the connections work. Okay? So what we're going to do to make this happen for you is we're going to print out the entire application. So the lab that you would have done, Lab 8, which is SQL, and Lab 9, which is the modularization piece, all of that's coming to you on paper, which means you're getting the answers to last week's labs. Merry Christmas. But no, you need that to do this. Now there's multiple files involved and all that, so what we're gonna have you do is we're gonna make you have 4 teams of 4 people. We'll split you up, 4 people here, 4 here, 2 groups of 4 down in our room on those whiteboards, and you have all day to draw this picture based on those printouts. It's going to take you all day because there's a lot of code there, obviously. But this will really get you in touch with what files are doing what and how all those codes connect. The hardest part of programming, I think, is understanding what function calls what function, what data gets sent, and what data comes back. And this really helps with that. Okay? So here's a nice simple example. I'll try and zoom in a little bit. So in this example, let me get my drawing pad open. There's 2 pieces to this exercise. One is the drawings. The other one is what you call the call stack. We talked about the call stack before, where JavaScript kind of does what it can do in what order that it can do it in. So for example, in this program, let's take a look at this program and see how this thing works. So somebody tell me the first line of code that actually runs in this program, that actually does something.
CNN?
Yes, this is the first line of code, right? Right here? Oh boy, that's not drawing well at all. Huh. Hold on. Oh, it's back to doing the thing where I have to press really hard. All right, we'll try that anyway. So this is 1. So I would say on the call stack, let's draw the call stack here. So the first thing that happens is the let name. Actually, let's put line 1, or line 3. That's the first thing. It goes onto the call stack. Does it execute right away?
Yeah.
Yes, it goes on and it runs immediately and it pops off. So it's on and it's off because it just sets a name and that's all that it does. The next line here doesn't actually run.
No.
Does this actually run?
No.
Does this actually run? Does this actually run? Yes. Okay, so the call stack has a call to say name. What does say name do? What does it actually do?
Call a function and send
It calls this function here.
Yeah, and say the other.
Just notice how I'm doing this. I'm drawing an arrow to what's going to happen next. So say name goes on. Then what line runs? line 6, right? So this is line 6. It runs. Does it run and pop off, or does it do something else?
Yeah, no, it calls another function.
It calls normalize.
Yeah.
So now we're going to go to normalize. Good morning, thank you. All right, thanks. So notice how say name is waiting for this to happen, waiting for that to happen. What does normalize do?
With the strings to uppercase.
Right, so this is going to return, so this returns back this, well, it returns back the string, right? I'm not worried about the words yet, but it returns back the string to here. So this sends Rosie, or Saint, this says Code Fellows in lowercase or mixed case. Sorry, my pen. It comes back as uppercase, right?
Yeah.
So say words, normalized has now happened, right? Normalized calls string to uppercase, and it returns it. So that pops off the stack.
Yeah.
Now we're back to this normalized call here.
Yeah.
The next line of code that runs is render.
Yeah. Call function to call.
Actually, this pops off too, right? Render happens now. So render does what?
Take the
Calling
call.
function of render.
And it sends what?
Stuff. Custom.
Code Fellows.
Yeah.
And does it console.log?
Yeah.
The line 6 will be deleted also.
Well, yeah, so console.log runs, then it pops off the stack, then render is done, it pops off the stack, and now we're back down to, where are we at? Down to say?
Line 6.
Line 6. Where's line 6? That popped off before. Oh yeah, no, sorry. I'm sorry. Line 6 popped off. Now we're back to say. Say is done, and the whole program finishes until it gets to. Now we're back to the call stack again. This is line 20. Console.log calls normalize. It just calls this, right? So this one here goes to there with Rosie,
And that with big row.
right?
Returned as a empty button.
Normalize calls string to uppercase. Sorry for this pen. And it returns back all uppercase. Then that pops off the stack, and then we're going to console log. Console.log, and then we're done.
Yeah.
So it's a simple little program, but you can see how it jumps around a lot, right? There's a lot going on there. This is the call stack exercise. So as you go through the program today, I want you to maintain this, okay? What you're probably going to do is draw them on the board and erase them instead of crossing it out, because crossing it out gets messy, but I really can't erase fast enough on the board here to do this. So you're going to write the lines that get called and erase them as the call stack happens. And when you're all done, this should be totally empty, right? So don't give me an empty board and say we did the work, right? Because it's going to be empty at the end. That's not the answer. The answer is to go through the work and do that, okay? Is that cool? All right, the other piece of this then is kind of what I did over here.
Yep.
But I want you to think about this in terms of, I'm going to erase this now, in terms of the boxes and what happens, right? So you've got these functions here. So draw a function as a box like this, say, and it takes in words. And then you have a function called render, and one called normalize. The normalize takes in string, render takes in stuff, and now you have entities you can draw between, right? So when this happens here, say calls normalize, which calls render. See how that works? So you can draw the arrows between them
Yeah.
and see how the relationships happen between your code. So knowing what calls what And in our case, with the City Explorer, you're going to actually write on here what the words were. You're going to say lowercase Rosie, and you're going to print out uppercase Rosie, or whatever the thing is. So on the inbound arrow, on top of the arrow typically, you're going to draw what got sent to the function. On the arrow that comes back, you draw back what got returned from the function as you do this. And if you look at that little bit of knowledge and go to here, let's go to this too. Here. Come on. I'm not sure what happened to my pen. There we go. It looks like this. So the thing that I just did for you ends up looking really, really big. Come on. Why can't I zoom in? Looks really big, right? You have the boxes for the code for what's running, and you can see that here's what's going in and here's what's coming back. We send a query in, we get back a result. So that's how I want you to approach this today. Really break this City Explorer application down to the tiniest bit of what's calling what and draw the pictures, right? Multiple colors works great. People's faces look great, right? Drawing cool pictures of servers looks really cool. However you want to do it, it's all good for me. Okay? Any questions on the exercise today?
I think in servers, it doesn't work like this, line by line, right?
It does.
But
It does.
that
So you're gonna, what you're gonna do is from your client though,
Yeah.
there's multiple calls to the server, right? So think about, oh, that's the wrong button. How our client works, right? So our web browser starts out with just a basic query of city. Goes to the server. Server goes to database. Do I have the city? If it's yes, it goes back, and then it goes back again for weather, back for events, back for Yelp, back for movies, and back again for trails. And each of these things does a whole bunch of work, right? If this answer was no, it goes to Google, comes back, goes back to the database, back to the server, back again. So you're doing all this hopping around. That's the essential diagram of how it all works. I want you to get into line numbers and what's actually on this, what's going here and what's coming back. So you're going to want to get into your network tab and take a look at how it works. Look at the code that we print out. We have all the code printed over here. So we're going to give you all the code. Do we have tape? It helps to tape those together and put them on the wall.
Oh, we can bring tape.
Yeah, because if you tape them all together, then you can draw
The
the
problem
lines.
is
of
they
what-
are.
Oh, they shouldn't be
double
two-sided.
faces.
No, they got to be single-sided.
Should we print them out again?
Yeah. Yeah, they should be single-sided because that way they can draw, like I did, the lines between the functions. Because you start by drawing the lines from function to function on the paper, then you go and draw the big diagram on the board.
Okay,
It
let me
helps
do
you do
this
that.
now,
So let's
actually.
go reprint those. All right, cool. So that's it. That's the lab for this morning. This afternoon at 2 o'clock we start a brand new track. It's going to be what we call the book application. It's going to be really cool. You go to Google, search for books, and then the ones you like you can add to your database for later, like a reading list type of thing. And you can create, update, delete all those records, and sort of have a nice little search program. So it's a fun application. It's a lot of work, but it's a lot of fun. It's actually pretty useful when it's all said and done. So we'll start that today. This will end City Explorer for good. I will do a short code review at the end of the day. I want to talk about the modularization a little bit, and I want to talk about the database part of locations a little bit. You will see that in code today. All day you're going to be in the different files because we have this thing broken out into all the files you want, and you'll see the locations SQL answer as well. So it's all here. So as you're going through it, you should answer your own questions about how this thing's supposed to work. If you need more, I can give you more time later on. Yeah? All right. Cool. I'm going to make teams here in a second, and that should be that. So I'll make you in teams of 4. Okay? And I'll put those in Slack for you. It'll be totally random.
much time do you have?
Till 2.
Drawing.
All day. Yeah, all day to draw.
Okay.
Takes
Lecture
time.
after 2.
What's that?
Lecture after 2.
Yes. I might lecture till 7 today. It's a lot of material.
Oh.
I'm kidding.
Tomorrow, maybe.
Maybe tomorrow, yeah. Actually, Wednesday or Tuesday's the one. That's I'm worried about.
Is it?
Yeah.
Wednesday. Okay.
Get your sleep. Get your sleep now.
We
All right.
print this out.